Hello everyone, welcome to our first class of the Python basics. So in the earlier video I actually showed you how you can set up your lab for coding in this coding camp, and now today we will be learning about some basic stuffs of Python. At first I wanted to let you know that it's not easy to learn or grasp every concept at first glance. You may need to see the same concept multiple of times or try it on your own to really understand the concepts. But gradually you will understand, and once you understand you won't forget. But I will try my level best to make the concepts clear, but at still you may have questions that you may ask me in the comment section. So as you can see, I have written lots of comments already, and this is our goal to complete in this video. So let me start without wasting any time, and the first thing is knowing about comments. So all the text that you can see are comments, and in Python comments starts with hash. And if I tell you about what are actually comments is, so comments actually helps us to describe our code, but it has nothing to do in writing our code. It just describe our code so that when we open our code after a long time, we can know or we can understand what we have written in past. So it's just for describing what our code is doing, and the compiler or the executor of the code ignores all these lines that are being started with the hash mark. So if you wanted to write a comment, we will start with a hash mark and then start writing our comment in plain English describing what this piece of code is doing. So we can write my first comment, something, anything we want. So my first comment, or we can write something like my code does this and that and so on. And doesn't matter what I write inside my comment, all these comments will be ignored. So for just your simplicity, if I just run the file, you will see nothing happens. If I again run, nothing happens. The only reason nothing is happening here is because all of the lines are comments and they are ignored by the compiler. So these are not codes, these are just text description that helps to describe our code. So I hope you have a good understanding of what comment is in Python. So I will not discuss any more about comments, and we will see writing comments as we go through the entire video. So let's go to the next thing, which is knowing about the print function. So when we talk about function, then it has a very broad concept in programming, but for now what you have just have to understand is function is a small program that takes some input, process the input and produces output for us. What does a big program does is it has a lots of functions combined with each other, interacting with each other for giving us or calculating the final output. But yeah, for in single terms you can say that a Python function is something that does only one specific task by taking some input and then returning the output. And the input types will be some data types that we'll be learning, which is on this section, and the output will be also some data types, right? So the print function in Python is a little bit special. What it does is takes input of any kind of data types and show us in the console. That's what print function does. So for using the print function, we will have to write the name of the function, which is print, and for using this function we will have to call the first brackets, and after first brackets we will pass the inputs here. There may be one input, there may be two input and lots of input, but in print function we can actually pass lots of input, like here, like input 1, input 2, input 3 and so on. So you can pass a lots of input, and all these inputs need to be a value or a variable. Okay, and now for our sake we will just write a string type just to showcase how print works. So you can see hello here. So the job of print function is to take a data type and then show us in the console. That's it. It doesn't have any more functionality. Its only functionality is to take different kind of values inside it as parameters separated by comma and then show us on our console. So as we have a little bit idea what print function does, we will be moving towards writing our first Python program with a simple print statement. So as we are done about knowing print function, I will comment it out so that the results doesn't disturb us when we are working on the next sections. So for writing our first Python program, it's normally recommended to write a hello world program in any kind of language you are starting for the first time. So we have write print hello world, which is the ritual in programming to be written as the first program. And now we can see that the hello world is on our console and the print function is actually doing its job. So this is what our first Python program is, like printing hello world on the console and understanding how print function works. It takes any kind of value as an input and then shows us on the console. So now I will again comment it back because we don't want the results to disturb when we are working with our next sections. So now we will be demonstrating today's goal, which is what we'll be building today. So for building this game, we will have to learn all these stuffs and then we can make actually the final game. But before even learning, I wanted to show you or demonstrate the game that have been made, and so that you know what you will be building after learning all these sections after. So now I will just change my workflow and switch to game, because you can see I have a game file, and then play run. And you can see that I am being told to guess the magic number between 1 to 100. So I will give 33. It's saying bigger, so I will give 23. Still bigger, 11. Still bigger, then I will give 7. Smaller, I'll try 9. And then I will try 8. So in this way you can see that I have guessed the number by seeing the helper logs, which are saying that if my numbers are bigger or smaller, and then it's guiding me to the right path of guessing the magic number. So this is actually the game, and it is very simple to build. But for building this game you will have to need little bit of Python basics, so we will be learning and jumping that right now. So what I'll be doing is shifting back to my main control flow, which is this main file, and also close this. So we are also done with demonstrating our today's goal. Now we will be learning about the basic data types that computer understands. So the first type is integer. So I will write a comment here, integer data type. So what are actually integers in Python? It's nothing but 1, 2, 3, or -5, -4, any kind of whole number which is like can be represented entirely is known as integer in Python. So if we use a print statement now and we write 5, then we will see that we have 5 on our screen, right? And like this we can write -3, and then we can write -2, then -1, 0, 1, 2, 3. We can write lots of numbers here, and I have already told you that print can print any kind of values separated by comma. So all these things you can see separated by comma are different kinds of input, and print statement takes all this input and show us on the screen. So if I run, so I can see all the numbers here, and all the numbers you see, whole numbers you see here, are known as integer in Python. So this is what integer types look like in Python. Now we will be seeing another type which is known as float data type. Okay, and in this float data type the numbers will not be in whole. Okay, it will be in fraction. Suppose 1 by 2 is equivalent to 0.5, right? So it will be 0.5, 1.45, or 7 point something, or even minus 45.63, 643, and so on. So the decimal numbers you see here, which are decimal point in between, are known as float data type in Python. Okay, and you can also print them to see if computer really understands them or not. So minus 4.5, and then suppose minus 1.32, then 0.5, and so on. So these all are floats. So you can also okay, let it run us and then see what happens. So we can also see that the floats number look like this, and computer also understands float. And then what comes is a string. So we will be learning about the string data type. Okay, and the string data type, what you have to do is write a quotation mark like this, and then you can write plain English whatever you want. Okay, so this is like when you wanted to write some text in Python, what you do is write this to quotation block, and inside that you can write any kind of text you want. And this text data type is actually known as string data type in Python that computer understands. So let us try to print a string. We have already tried to print a string above by printing hello world. So I will just say I am a string, and then if I try to run it, then we can see that I am a string is being printed. So these are the three basic data types, and the next data type that is come is boolean. So we are familiar with boolean data type. So boolean data type has only two values, one is true and another one is false. Okay, so true means a statement is true, and false means a statement is false or the value is false. So boolean data type is very beneficial when we will be learning conditionals, but for now you just have to know that true and false exist, and they are actually evaluated when you actually write a condition. So we can also print true and false, and they are actually a little bit different. So we can say true comma false, and we have supplied two inputs to print function, and these both are like boolean data types. So if you run and see, so we can see true and false. Okay, and we are almost done with our basic data types, I think. So these are the mainly the four basic data types you have to know, and there are few advanced which is known as list, dictionaries, and so on, but we will not be learning those advanced data types in today's class. So we are good with these four data types right now, and we will be trying to work with these four data types. And as what I was trying to show you is, as we know that the print function can actually accept multiple inputs, let it be integers, let it be float, let it be string. So I will try to write a mixed print function with all the data types. Okay, so mixed print function, and then what I will write is write a print, and then you can see that I can write a string here, then I can also write an integer value here, I can write a float value here, and I can also write a boolean value here. Sorry, it will be something like this. And you can see that this print function takes four inputs. Okay, and all of them are different kind of values that computer understand. One is string, one is integer, one is decimal point, and another one is boolean. Okay, so we can see that print is a function that can take multiple types of input or even one input, and that needs to be a value or a variable. We will be learning variable very shortly, but for just now we are using the values directly, but we can also store these values inside variable by giving a different kind of names and then use it in our program, but we will be learning it little bit afterwards. But I hope you have understood what the basic four data types in Python are, which are integer, float, string, and the boolean one. So I will try to keep this boolean one above. I don't know how it came down. So yeah, So in this way, we actually know how computer understands different kinds of values. And this is all I have to say about data types in today's class. So let's run it once again, and we can see that string 32, 5.5 true, everything is coming, and also our previous results. So before moving to our next section, I will be commenting it out like this. And my purpose of commenting it out is when we'll be moving to next section, I don't want the print statements to bother. So that's why I am commenting everything out after completing each section. So let's move out to our next section, which is learning about basic arithmetic operations. So when we say arithmetic operations, we have four operations, which are addition, subtraction, division, and multiplication. Okay, so these are our four arithmetic operations, and we can perform these four arithmetic operation with the values or the data types that we learned earlier here, right? Like integers, on strings, on basically arithmetic operations are only for the integer and float data type, but you can also perform the addition operation on the string. But for the boolean, you cannot perform this arithmetic operation. For boolean, there are something called known as logical operators. So we will be also learning about logical operators, but let's run about arithmetic operation first. So if we write a print statement, and now if we have two values like 5, right, and then we can say plus, and then we can say 5. So what it means is 5 is an integer type, and this 5 is also integer type, and we are doing an arithmetic operation by adding a plus sign. So if we run this statement, we will get 10. So like this, we can replace this arithmetic operation sign with subtraction. Then we can do our division, and then we can also do a multiplication. So this is the way we can do all these four operations, and I wanted to also show you a fancy operations. Instead of 1 star, if we put 2 star and then 2, then it actually means 5 square. So if you want to square a number, you can use this double star operator. What it will do is perform the power of the base. So 5 is the base and 2 is the power, and we know 5 square is 25. So if you sometimes wanted to like multiply 5 7 times, okay, or 3 or 4 times, 5 times, whatever you want, okay. So now you can see that I have multiplied 5 1 2 3 4 5 times, and then we are getting the result of 3125. But we can do it very easily by saying that I want to multiply 5 for 5 times, and then we will also get the same result, which is 3125. So this is not an arithmetic operator, but it's a fancy operator that existed in Python, and that's why I have just showed you. And then another interesting thing is you can do these arithmetic operations between the float data type and the integer data type. Okay, so now if I say like 1.5 multiplied by 5 times, or let's say 0.5 multiplied by 5 times, will be something like 2.5, right? So if I run, so we can see 2.5 because half of 5 is 2.5, and so that's why we are seeing 2.5 in our console. So which means that we can also perform these arithmetic operations between the float and also the integer data type, and then we can also change the sign to see if it works. So 5.5, we can subtract 0.5 from 5, which will become 4.5, and then we can divide. And this is little bit tricky because dividing, okay, let me show you. It should be 10, I think. So you see it's 10. So it's like when we divide by a fraction, then 0.5 is like 1 by 2, and then it becomes reciprocal, and then the 2 comes and gets multiplied with 5, so 5 times 2 is 10, and that we are seeing on our screen. But you just know that you can also perform a division operation with also float and integer type mixed. So these are the four operations actually that we have seen. So what I will do is to show you all the operations on a single print statement. I will do something like 5 times 0.5 comma 5 by 5 comma 5 plus 1.5, and let's say 5 minus 3. And you can see that we have performed all the four arithmetic operations, and then after performing the operations we are passing the values of the results of this operation to the print function. And what print function will do, just print all the results so that we can see it. So after running we can see that it's 2.5, then it's 1, then 5 plus 1.5 is 6.5, and finally 5 minus 3 is 2. So the results are accurate and the print function is working as expected, and so also the arithmetic operators that we see here. So now let's move to the logical operators. Okay, logical operators. So there are very few logical operators. One is equal, okay, one is not equal, one is greater than, one is smaller than, another one is smaller than equal to, smaller than, sorry, so another one is smaller than equal to, and another one is greater than equal to, and another one is modulo. Modulo actually falls under arithmetic operations, so I will not include it here. So these are actually the basic logical operators, and there is also like and or. So, and also there is something called XOR, but XOR is little bit advanced, so we will not understand XOR right now. So now if I use a print statement here and try to do something with these logical operators, what we have to understand at first is logical operators uh, will actually resolve a value of true or false. Okay, when we perform a logical operation, their result is always either true or either false. It's not a numerical output, rather it's a boolean output which is true or false. So let's start. If I say 5, and if you put double equal, which is this equal sign, okay, so if you wanted to compare 5 with 5, and we are saying that is the value of 5 is equivalent to 5, and if we run it, okay, let me comment the previous section so that it doesn't disturb us. So we can see true, that means 5 is equivalent to 5. But if we make it 6, we are getting false because 5 is not equal to 6, right? And you have to focus on that I am using two equal sign, not only one, because in programming we use only one equal sign when we are actually assigning values to the variables that we will be coming afterwards. But for now you just focus on that when we wanted to compare two numbers are equal or not, we have to use two equal sign. Okay, so we have compared 5 and 6, they are not equal, and we can change this number like this, 8 and 7, and then try, and we will again get false. 8 and 7 are not equal, but if we make that thing 8 again and run, we are seeing that 8 and 8 are equal, right? And then comes the next operator, which is not equal to. So if I write 8 is not equal to 8 and run, we are saying false. Why false? Because 8 is equal to 8, right? And we are trying to say that 8 is not equal to 8. So computer will say, okay, the thing you're writing here, like you are saying 8 not equal to 8, is resolving to false, because we already know that computer is smart enough to know that 8 is equal to 8. So I am saying that 8 is not equal to 8, so that's a false statement. So just focus that how you write not equal to. So you have to put an exclamatory mark and then an equal to say that 8 is not equal to 8, and then it will say false. But if we change it to 7 right now, so we all know that 8 is not equal to 7, and if you run, then we will get true, right? Because 8 is not equal to 7 and this statement is correct. So this is how not equal to works. So we are done with our equal and not equal. Now comes greater than. So if we write 8 is greater than 7, so we can see that the opening or the big mouth is on the 8, so it will be true because 8 is actually greater than 7, so it's true, right? And now if I actually reverse the thing, okay, give 7 here and put 8 here, so you can see that we will be getting a false because 7 is not greater than 8. Similarly, we can change the sign, and now this changing the sign means that we are trying to say that 8 is bigger, because if you think it as a mouth of crocodile, like how kindergarten teachers teaches that if it's the mouth of crocodile and the mouth is facing towards the number, then we are trying to say that this number is bigger and the other side is smaller. So now we are trying to say that 8 is greater and 7 is smaller, and that's a true statement because 7 is smaller than 8, and if we run, we will get true. So these are very basic mathematical stuff. So I hope you will understand, and then move to the next, which is smaller than equal to. Okay. So how smaller than equal to works is 7. I 7 is smaller than equal to 7. So what we are saying that is 7 either smaller or equal to 7, and the output will be true because 7 is not smaller than 7 but it is equal to 7, so it will return true. Okay, and if I say, let's increase the number or decrease the number to 5. Okay, now I'm saying that is 7 is smaller than or equal to 5, and we will get false because neither 7 is smaller than 5 nor it is equal to 5, so the statement will become false. Similarly, if we change this sign to like this, then it becomes greater than equal to that sign I was talking here. Okay, so 7 is greater than 5, so it will actually return true. And even if you put here 7, sorry, 7 and then try, so 7 is actually equal to 7, so it will still return true. Okay, but if we change it to something uh, very small like 3, so we know that 3 is not greater than 7 or nor it is equal to 7, so it will return false. So this is like a basic very common sense like thing, like what we will be writing here. We can already see the numbers on the both side and then ask our question that what will be the result of this evaluation, true or false, right? And the final thing that we are that I want to show you is and or. Okay, so you can actually write two conditionals and join it with and so if we see something like true and true. Okay, so when we write and, we want that all the conditions will be true, so this will result true and true will give us true. But if we make a single one false, it will give us false. So we can have actually lots of condition chained with, there is no limit how many conditions we can chain like that, but we can see that in this U chain, okay, there is a single false, and that means that the whole statement will become false, because I want this to be true and 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 so on. So if the entire statement or chain of AND is not true, then it will resolve to false. So if I write run, is false, right? But as soon as I make this false to true, you will see that it has get converted to true. So AND means that whatever or what number of conditions I'm chaining together, I want this to be true and this to be true and that to be true and so on. So I want everything to be true, and when we want to satisfy multiple conditions, then we actually use the AND statement. So we can think it of like, say 5 is greater than greater than 3, then we will say and, then we will say 7 is smaller than 4. Okay, so now if we say this is a condition, right? 5 is greater than 3, so this condition is true or false. We know that 5 is greater than 3, so it's true. 7 is smaller than 4, is it true or false? It's true. Sorry, 7 is not, sorry, it's false, because 7 is not smaller than 4, so it's false. And we are using an AND statement, so what does it mean? True and false. So when it is true and false, so we want that to satisfy both conditions. We are saying the computer that we want this and this, but then the computer say, okay, you want this and this, but this one is wrong, so your whole statement is wrong. So if we run, we are getting false. But as soon as we make this condition correct, like 7 is greater than 4, and try to run, we get true, because this condition and this condition both are true, so it will result true. So this is like a very basic, and let us switch to the OR one, which is the last one. Okay, and for OR that's the same thing, but OR actually wants only one condition to be true from multiple conditions. So if I show you like false or false or false or false or true, so what do you think what this expression will return? It will return as actually true, because when we are writing or, we are saying, okay, I may have a coffee or a tea or juice or milk, or like I am saying or, so doesn't matter, I will pick only one. So so if I go to a restaurant and say I wanted to have a coffee or milk or juice, so if any of the options are available in that restaurant, I am happy, right? Because I am not wanting to have all of them, but I wanted to have any one of them. So there's the difference between and or. When we say and, if I say I want burger and sandwich, I am expecting that the waiter will give me both the burger and the sandwich. But when I say that give me burger or sandwich, then the waiter will say, okay, take, we don't have burger, take sandwich. Or they will say, okay, take sandwich, we don't have burger, because we are saying or here, right? So in this false statement we are saying false or false or false or false, but as one is true, so the computer will say, okay, it's true because I have something to offer, which is this one. But if everything is false, okay, the computers will say, oops, I don't have this option. So everything is false, so you are saying I want this or this or this or this or this, but everything is false, so the restaurant doesn't have anything to offer you, so it will say false. So we can say that it is false. But even we make any one of these true, so we can see that the whole statement has turned into true. So how we can actually use it in numbers? So we can write 5 is smaller than 32, or 6 is greater than 73. So now we know that this condition is correct and this condition is wrong. So computer will say, I am saying the computer that is any of these conditions true? So computer will say this condition is wrong, but this condition is true. So yes, so the result of the entire expression is true. So after we run, we will see true, because one of the expression here is correct and one of them is wrong. So we are just expecting computer to tell us, is any of these expressions that we wrote here, like the logical expression, is any of the logical expression correct here? And the computer says yes, I have found one which is true, so that's why it will return true. But if I say and, then I am trying to mean that I want both the conditions to be true, but I know that this condition is false. So computer will say, oops, no, you want burger and sandwich, but we don't have burger and sandwich, only we have burger, which is, this is true but this is false. So you can actually make it similar with analogy. And then if you go back to or and make the both of the condition false, like 5 is greater than 32 and 6 is greater than 73, then you will see that we are getting false, because computer is saying neither of them is true. So there is not a single one which is true, so you will get false. So this is all about logical operators. When you will code and when you will practice, you will get a much more about the logical operators. So this is like a slight introduction about how logical evaluation works, and I hope you have understood how logical evaluation works. So that's why I will go to the next one, which is the learning about variables, because as we know about the operations we can perform and the values we have in our tools, like the integer, float, string and boolean, and we also know that how to use print function, we now know how to do arithmetic operations, we now know how to play with the logical operators with greater than sign, or, and, equal to, and so on. So now we will be starting learning about variables, and we can see that we are very much close to our goal, which is making the final game. So let's start about learning variables. So we have already seen that these values are raw, right? And we wanted to name it something that makes sense to us. We just don't want it to directly use these values, or also we also wanted to store it sometimes so that we can modify it later. So for writing a variable, you will write whatever name you want. So you can write something like my first name. So my first name is, suppose, Rahat. So now I have to put a value inside a variable. And what value can I put inside a variable? I can put any kind of value, but as we have learned only 4 types of value right now, so we can go with integer, we can go with float, string, boolean, whatever we want, but I will go with string because my name is a string or text based data, so I will go with string and write my name. And now it's a variable. Okay, and now if we use the print statement, instead of saying Rahat like that, we can call it something like my first name. And if we run it, we are saying Rahat. So what does it mean is that this variable is like a storage, and it is saying that, okay, I am holding a value, or I am holding a string that contains Rahat. Okay, so in this way we can give the names to our value in different ways. So now we can write like uh, a number. Okay, so we can write a number and then say number is equal to, let's say, 32. we can name it anything we want. Like we are just giving a name for this specific value. That's it. This name can be anything, but you just have to remember that you cannot name a variable like this. Okay, see, computer started complaining. It need to be a one single word. It can end with numbers like number 1 2 3, doesn't matter. And but it cannot start with number, remember. So if you start a variable with number, computer will complain. So for writing a variable, you can write anything, but there must be no spaces between the words. It must be a single word, and it must not start with number. So there's the two things you have to remember when you're writing your variable names. So we can write number 1 is equal to 32, and we can write again number 2 is equal to 45. See, so I am easily naming my values to a different name. So then I can write something like decimal number. Okay, let's name this variable decimal number, and then I can put a decimal value here. Who cares? Or we can also name it like deci2, and we can write zero point 0.5 here, or minus 0.5, whatever you want. So here the only thing I wanted to show you is the value we have learned, like boolean and all the stuff. So we can also write boolie, something like that, and then we can put a true here. So as you can see that these types of value, we have learned about all these value types, and now what we are doing is just naming it, giving it a name. So instead of directly saying true, I'm just saying that okay, now true will be represented by the name boolie, because suppose we are humans, we all are humans, but for recognizing everyone we need a name, right? So similarly to this, to recognize 32, we may need a number 1. For we have named it number 1. For recognizing 45, we have named it number 2, and so on. So now we can also print all the variables using the comma, because we know how to use the print statement right now. And then if we run, we can see all the values. See, my first name gives me Rahat, and then number 1 gives me 32, number 2 gives me 4.5, number 2 gives me 45, decimal number gives me 4.56, and deci2 gives me 0.5. And we can also add the boolean one, boolean. So if I add the boolean variable, what I can see, the true one, right? This variable. So we can see that instead of directly calling by the value, we can actually refer to their names and then directly use it in our code. So we don't have to hard code the values every time. We can name it and then call by their names instead of calling them directly by their values. And that is very much beneficial, because when we wanted to store something and then update, it is very much useful. So just for one more example, I will actually remove all these things and comment it out, and then give you a new example. So say num1 will be 5, num2 will be 60, and now what we can do is compare. So print, so let's do some logical operations. And now if I say number 1 is equivalent to number 2, so what do you think? What's the answer? We know number 1 is 5 and number 2 is 60, so number 1 is not equal to number 2. So see, now instead of directly writing the values like 5 is equal to 60 or not, we can refer to by their names, which is number 1 and number 2. And that is pretty cool, because we can actually want it to update. Okay, so now we can say that okay, and now we can update the number 1 to 60 and then try to print it again. Number 1 equivalent to number 2. So now if I run, you will see two print statements. So one is false, one is true. So what is actually happening? So we are saying number 1 is 5, number 2 is 60. Then we will say, can you say if number 1 and number 2 are equal or not? And then the computer says, okay, 5 and 60. Nope, number 1 and number 2 are two different numbers. And then we are changing it and saying that, okay, make number 1 to 60 right now. So we are discarding this value and updating the value of this num1 to 60, and then we are comparing again, is num1 is equivalent to num2. So as we have updated the value of num1 to 60, so print num1 equivalent to num2 will be true, because 60 is equal to 60 and we have changed the value of num1 from 5 to 60. So now 60 is equivalent to 60. So this way we can see that how we can actually use variables and also update them and also reuse them. So that's why variables are very useful. So I just wanted to know you about variables up to this, that we can name our variables and then we can call by those names or use those values by those names, and we can also update our variables. That's it. And then we can also do operations in our variables. So we can make a new number called number 3, and we can say that number 3 will be nothing but the sum of number 1 and sum of number 2. So what we are saying is that, okay, we have a new name, number 3. Number 1 is 60 right now as we have updated. Number 2 is also 60. So number 3 will become 120. And now if you want, we can print number 3 and we can run. And we can see 120 right now. Okay. So if we just go through this code, so what is happening is computer is saying, okay, number 1 is 5, number 2 is 60. Is number 1 is equivalent to number 2? No, 5 is not equal to 60. So it prints false. After that it goes to the next line, and we are updating number 1 to 60 right now. And then we are again telling computer, check number 1 is equivalent to number 2, and now this time the computer is saying yes, 60 is equivalent to 60. So now it is giving us true. And then we are saying that there is a new variable called number 3, which will be the sum of number 1 and number 2. So number 1 was updated to 60 and number 2 was 60 from before. So 60 plus 60 is 120, and when we print num3, we are actually getting 120. So this is how variables are very useful. You can define your own variables, call by their name, update them, do arithmetic operations, and also do boolean operations inside the variables, and so on. So if I give you one more example, so let me comment it out because we don't need it anymore. And if I give you another fun thing about like boolean operation, so I will say something like condition 1 is 5 greater than 3, condition 2 is equal to 7 smaller than 8. Okay, and then I am saying result is equal to condition 1 and condition 2, and then I want to print my result. So what do you think the answer of the result will be? So the answer of the result will be true, because what is condition 1 value? 5 is greater than 3, so it will become something like true. Okay, and as you can see that I can also write comments on the side of my code. It doesn't have to be on the top of the code always. You can also write comments on the side of your code. And 7 is smaller than 8, so it's also true. And then we are trying to make another variable result and saying condition 1 and condition true. So we are saying true and true. And we have already learned how AND works. And wants all the conditions to be true. So as condition 1 and condition 2 both are true, result will be equivalent to true. So what should be the result of doing the print? It should be true. So let's see. See, we are getting true. So in this way, you can also do the logical operations, the arithmetic operations, then updating the values. And now if you want, what you can do is change the condition to uh, equal to false, like this. So we are directly saying that condition 2 will be false, and then we will be doing again, we will say please update my result, because we already have the result variable, right? So we are saying that now condition 2 that we have earlier, which is 7 smaller than 8 true, make it false. And then we are saying please update our result with condition 1 and condition 2, and then we want to print our result again. So what do you think, what will be the result this time be? So condition 2 has now become false, but condition 1 is still true, but true and false and wants all the conditions to be true. So as condition 2 has become false due to updating the condition 2 variable, so the new result that we are also calculating by updating the previous result variable will be converted to false, right? So if I run, see the next output is false. So at first it is printing true for condition 1 and condition 2, and we are updating the condition 2 to false, and then when we are calculating the result we are getting false right now, because as we have set the condition to false, then false and true becomes false, and the result value is updated to false from true, and then we are seeing the false in our console. So this way you will actually have to make an idea of how logic is working, and you will learn it gradually. So I hope you have understood how to deal with variables and how to use the previous concepts of numbers, data types, uh, operators, etc., etc. in your code. So now I will actually switch it off, and then I will go back to conditionals. So now we are moving to conditionals, and conditionals are actually dealing with boolean data types which are true and false. So if we write a condition with if statement, so if, then we will write the condition here. So we know how to write a condition. We write condition with conditional operators. We have learned about the conditional operators from here. Let me go back and show you. Yeah, from here, equal, not equal, greater than, smaller than, equal to, greater than, equal to, and or. So all of these are for me making a condition. So inside the if, we can only do a condition. So let's say if 5 is greater than 8, then we will have to put a colon here, and then we have to put enter. And after putting enter, and then you can write a print statement here and say 5 is greater than 8. So for some reason my tab has been switched to, okay, so then you can say that 5 is greater than 8, and then if you run, okay, so we are not getting any print statement because 5 is not greater than 8, so nothing is coming on our console. But as soon as we change the sign, we will see 5 is greater than 8. So how conditional works is like, if a portion of a code is correct, then I want you to execute this code, otherwise I don't want you to execute this code. So it's like we are saying something in our real world that if I get some money from my mom, I will buy this. Otherwise, I will sit at home and enjoy a movie because I don't have money to buy something. So similarly, if works in computer like that. Let me just check if the okay, the recording is happening fine. So we are doing the same thing here. We are trying that if this is true, I will do or execute these lines of code. Otherwise, so then we will use an else statement. Okay, and then we will say print, and then we can say 5 is not. So we will say our 5 is smaller than 8. 5 is not smaller than 8. So what we are saying here is if 5 is smaller than 8, I want you to execute this line of code. Else I want to execute this line of code. So here what you have to see, a very important thing is known as indentation. So how computer will understand what lines of code will it have to execute if this condition is true? How it will understand? So to make it understand, we will use indentation, and we make indentation by tab. So as you can see, I have set my tab settings to 2. So when I will perform a tab, okay, and then do the print operation, then what I am saying is like if 5 is smaller than 8, I want this line to be executed, because if there are multiple lines. Just for an example, if I remove this and say print uh, normal or something like that, okay, so and then make this condition false, like 5 is greater than, and then inside here I will give inside if block, okay, and now if I run this code, I am only getting normal. Because why normal? Because computer tries to execute this condition, and this condition turns out to be false, and then all the code that's inside this block are ignored by the computer. Why? Because I wanted only to execute this line if this condition is true, but as this condition is not true, so what I actually want is to skip. So how computer knows that I have to skip this line because this condition is false? By saying this indentation, because it knows that what is inside this if block by saying this indentation. So now if I write another line, so suppose we can also write an if statement inside also. 7 is smaller than 9, and then we can write print inside second if block. So now we can see that as this condition is false, all the things which are in the level 1, so we can see that these 3 arrow marks. So how many lines of code are there in the if block of first if block? Okay, so let us write inside first if block. So how many lines of code are there inside the first if block? 3, right? 1, 2, 3. How many lines of code are there in the second if block? Only 1, right? So this way we understand like what lines are inside what. So when this condition is false, we will not be executing these 3 lines, because these 3 lines are inside inside this first if block. So if this condition fails, all this level, you can see that the first level, all these 3 lines will not get executed, computer will ignore. And suppose this becomes true, okay, 5 becomes smaller than 8, then it will execute this line, and then it will check, okay, 7 is smaller than 8, sorry, 7 is smaller than 9, and then it will try to execute this line which is inside second if block, right? But what if we make it if 7 is greater than 9? So computer will come and say, okay, I'm inside the first if block. 7 is greater than 9. No. So what line I have to ignore? This line, because this line is inside me. We can see this is at the second level. It has two arrow signs. That means level 1, level 2. And what lines are inside this if statement? Only this single line. So computer says is 7 is greater than 9. Nope. So I will ignore this line and then come back to my main control flow, which is normal. Okay. So what we can do is write here for understanding indentation better, we will write here starting, then we will write here ending, and we can see that there are two if blocks, one nested inside another. And if we run this code, so okay, let me correct my spelling and then run. So starting inside the first if block and then ending. See, it doesn't executed this line which is inside second if block. Why? Because this condition failed. And what lines are there inside this condition? This one line only. So this condition is failed, so the computer will not execute the lines that are inside this if statement. How computer understand what are inside this if statement? By seeing this two indentation, and then it understands like, okay, so I am saying these two indentations and I am inside, this line is inside this if block, and this code fails, so this will also fail. And if I actually make this condition false, like 5 is greater than 8, and run again, see, starting and ending, where did my, okay, just let me just turn it off, where did my the inside first block went? It disappeared, right? Why? Because it is starting, then it says is 5 is greater than 8. No. So how many lines are there inside this if block? 1, 2, 3. It will ignore all these 3 lines and then it will print ending. So see, it started, it tried to go inside this if block, okay, these 3 lines it tried, but it failed because of the condition resolved to false, and then it come back to ending. So this is how indentation works. So when we wanted to put something inside an if block or any kind of blocking thing, then we actually use what is known as indentation to include that these lines of code are inside this specific block. So this is how indentation works in Python. I have spent a lot of time in indentation because I really wanted to understand how this blocking thing works. But still, if you have any questions, I will not extend it anymore. Let me know in the comment section and I will come back to speaking about conditionals. So I will say if 5 is greater than 8, so print I am greater than 8. Otherwise, if this condition is false, what we wanted to do, we want to print I am not greater than 8, right? So we are saying that we are getting I am not greater than 8 because 5 is not greater than 8. And there is, you can chain multiple conditions with an elif block. So the elif blocks looks like this. Elif, suppose 7 is, or you can say like 5 is equivalent to 8, and then you can print what we can print. What we can print is I am equal to 8, and then change our statement that I am smaller than 8. So now if we see how the elif work is like, try this condition, if it fails then try this condition, if this condition fails, then try these conditions. So now if I make this condition pass by saying something smaller, so now we know 5 is greater than 3, right? And now if I run, says I am greater than 8, but it doesn't execute it these two lines. Why? So because it says that try this thing, if 5 is greater than 3, then print. But what if this statement fails? Then try this and see if 5 is equivalent to 8, and if this fails, then try this, that I am smaller than 8, and so on. So, and sorry for the statement because I've changed it to 3, so you have to change it to 3, but I think you are getting how the things are working. So the thing is, like, if this condition is successful, only then this line will execute, but if it fails, these are like backups. So you can check this condition, and even this fails, you can check this condition, and you can add multiple elif blocks. Okay, suppose 7 is greater than 7 is equivalent to 9, print I am, or we can say 7 equals to 9, and then here we can say 5 equals to 8. Here we can say 5 greater than 3, and here we can say all conditions failed. Okay, so we can see that 5 is greater than 3, but what we make this condition fail? Something like this. So we are getting all condition failed. So 5 is not equal to 8, 7 is not equal to 9, and all condition failed. But what do we make this condition pass? Like 5 is equal to 5, sorry, and then run. So this is saying us that 5 equals to 5 because it tried the first branch, it failed, it tried the second branch, it succeeded, so it didn't execute all these branches. Okay, and then if we also make this condition fail, like 9, and then make this condition pass and say 7, and then say we want to run, so we can see that 7 equals to 7, and this is because first condition failed, then we tried the next condition, failed, then we tried the next condition, we passed, so we are ignoring this one. And finally, if everything fails, like we'll just make it fail, then we will see at last all conditions failed. So we failed this one, we failed this one, we failed this one, and we come here and we say all conditions failed. And you can see that every time we can see that if this condition is successful, then we are using one tab to indicate the indentation and what code we will execute if this condition is true. So we can execute, of course, multiple lines of code. You see, if you see tab, and we can say print say statement 2, and then print statement 3. So in this case, you can see that in this if block we have 3 statements. So if this passes, all this code inside this block will execute. Similarly, we can also put more code inside this block, more code inside this block, and how computer will check is like, okay, if it passes, then I won't execute these lines, but if it fails, I will try my first backup, then I will try my second backup, then I will try my last backup, and all the things fails, and in my last backup I'm just saying that oops, all the condition failed. So this is the last, like if everything all of my condition fails, what will I do? I will do inside in the else block. Okay, so this is what I wanted to know about conditionals, and we have came to an end about conditionals. And if you have any questions, let me know, but I don't want to extend conditionals anymore. So this is what conditionals was. So now we'll be shifting to loops. So now we will be learning about loops. So we use actually loops when we wanted to repeat something. We wanted to do it for multiple times. So before understanding loop, the thing we have to understand is the range function. So if we say range and say how range function works is like if you only supply one number, so you can see here stop, right? You can already see the help of the compiler. So it's saying that it takes one parameter called stop. So if we write here suppose 30, it means a set of numbers from 0 to 29. So it will start from 0 and end at 29. It will not include 30. And if we want to change the starting point from 0, we have to change it by giving the starting point like this. So now it's 1 to 30. Sorry, 1 to 29. Now it's 10 to 29. 30 is not included. So if you wanted to include 30, you have to make it 31, because the last number is exclusive. So it will not include 31. It's saying that starting from 10 up to 30 excluding 31. So it's like an upper bound that you have to understand. So this way we can say it is the starting point, it is the ending point, and then we have another parameter for this function, or the input for this function, which is known as skip or step. So if we give 2, then we will jump every time 2 step, like skip 2 step every time. So we will print 10, then we will skip 2 numbers, which is 11, 12, and then we will print 12, and then we will from 12, then we will go 13, 14, and so on. So let's use the range function, and then we will actually understand how range function actually help us to do the looping. Okay, because we always use this range function with a for loop. So let's learn about for loops. So there are two kind of loops. One is for loop and another one is while loop. So for how to write a for loop is for, okay, here I is a variable, and we already said that you can name a variable whatever you like, not I, not anything else, whatever you like. So I can say num also instead of I, then I will have to say in. Then in is a special word, so keep in mind you have to write in, because we want to say that okay, for every number in the range do something. Okay, so if range has 100 numbers, for every number in range do something with this specific number. Okay, so if we just write only one number here, suppose 30, and then we can, like the conditional, we will have to give a colon to say that I am declaring a new block, and then what we wanted to execute for 30 times. So for that, if I write print, and then I know num is a variable, and so we can print the variable. Okay, and if I run, so what I will do is just close the previous results, comment it out, and then run again. So we can see that from 0 to 29, right? So what is range 30 is doing is giving us a set of numbers containing from 0 to 29, because 30 is excluded, right? And then what we are doing is for every number we are picking it like 0, assigning that number or the integer to the num variable. Okay, and then we are printing it. Then we are picking 1, assigning it to the num variable and then printing it. Then we are picking 2, assigning it to the num variable and printing it. Okay, so we can do much more things. Suppose it's 0 to 29 right now. So what we wanted to, if we wanted to print from 1 to 30, so we can just add 1, right? Because every time it will pick 0, we will add 1, so it will become 1. 1 will become 2, 2 will become 3, because we are adding num plus 1 every time. So it will pick all this number one by one, and while we are printing, we will be adding 1 with them. So if we run, see, 1 2 3 4 5 6 up to 30. But if you don't want it to do it like this, what we can do is remove this one, say that our starting point will be from 1 right now, and as 30 is exclusive, we will make this 30 to 31. This is also another way you can do it. You have to define the starting point then, and then the ending point increased by 1 because it is exclusive, and then you will try to print, and still we get 1 to 30. And now comes step. So how step work is, if I say the step is 2, then after printing 1, it will skip 2 things and then it will print again. So if we run, see, 1, then it skips 2 and like one number, and then it comes to 3, and then 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So how step work is, like, it will start at 1, and every time until it reaches its final destination, which is 30, it will keep adding 2 and then keep going forward. It will not print sequentially, it will jump every time by an addition of 2. So normally it is set to 1. So if we set it to 1, then we can see that it's 1 to 30, because 1, then 1 plus 1 is 2, 2 plus 1 is 3, and so on. So this is the way actually looping works. So if you understand how range function works, you actually understand how loop works, because you already understand how blocking works. So you are creating a loop, and then you wanted to do something for multiple times, and then you have to write like again some codes inside that loop block, right? So you have to play actually with these 3 parameters to actually understand how loop works. So as you can see, 131, and with a step of 1 gives us 1 to 30, and then if I change it to like 100, so it will start at 1, end at 99. Okay, but what if we want like a jump of 5, like 1, then 6, then 6 plus 5 11, then 11 plus 5 is 16. So what we want, jumps like that. So for jumps, we will just increase the count from 1 to 5, and if we run it again, see, 1, then 6, then 11, then 16, and all those stuffs. So this is very useful. Suppose if you wanted to do something, like if you wanted to do like a times table of 8, suppose, so you can keep like 8, then times of 800, and then you can go like a step of 8. So then you will see the times table of 8. 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40, 8 six are 48. Say like just defining like this, you can actually generate the times table of 8. So what it is doing is starting at 8, ending at, actually I have to give 8 into 100 plus 1, which is 801. So we can write something like this, 801, and then again run it. So you can see it's up to 800, right? So it goes from 8 times 1 to 8 times 100, which is 800, and every time it's skipping by 8. So at first it starts at 8, and then it says that okay, I want to skip by 8. So 8 plus 8 is 16, and then again it skipped by 8. 16 plus 8 is 24, and it goes on up to 800. Okay, so this is the ending point, this is the starting point, and this is the jump. And then you actually see how many times you actually want. So if you count from this to this like this, there are 100 entries. Even without counting and knowing, we know that it started from 8 times 1 and it ended at 8 times 100. So from 1 to 100 it's like 100 entries. So that's why here we can see that it will be 100 entries. So if I just make a variable which is called, say, count. Okay, count is equal to 0, and every time what I will do is increase my count. Okay, so I will say count is equal to count plus 1. So every time I'm updating my count by 1, and once this loop is over, so how many lines are there inside loop? Only one. Once this loop is over, what I will do is start to print it and print my count, and if I run it right now, we will see 100. See why the loop ran 100 times? Because we already said we start at 8 times 1, we ended at 8 times 100, and every time we are jumping by 8. So this range is a set of 100 numbers, and every time we are getting one number, and we are looping for 100 times, and in each time we loop, we are increasing the variable count by 1, and then when the loop is over, we are printing the final count, which is 100. So these things may look little bit very complicated at the beginning, but this is not actually that much complicated. The more you practice, the more you can. So this is all about I have to say about the for loops, and now I will jump to the while loops. So I will just switch it off and come to while loop. So when we write about while loop, we will say start it with while, and we have to give a condition. So let's say we will declare a variable called count, and we will say its value is 30. Okay, and now we will write a condition while count is small greater than 5. Okay, we will say print, then we will print the count, and then what we'll do is count is equal to, and then we'll say count minus 1, and then we will say print count. So here if I just say what's how while loop works, we are setting a value of count to 30, and we are saying that as long as count is greater than 5, keep repeating the code that inside the while loop. So what are the code inside the while loop? These two statement, right? So count is equal to 30, 30 is greater than 5, execute these two lines of code, come back, check again, again execute, come back, check again. As long as this condition is true, keep running these two lines of code. That's it. So we are seeing that we are printing the count every time, reducing the count by 1, and again checking if count is greater than 5. So if I just ask you a general question that what will be the final result here, so it will be nothing but 25, I think, because 20 sorry, not it will be 5, I think, because it will keep reducing by 1, and when it will be 6, it will become 6 minus 1, and when it will become 5, 5 is equivalent to 5, but 5 is not greater than 5. So here the count will actually be equal to 5. So let's see if the answer is 5 or not. So the final answer is 5, but you can see that we are decrementing the count one by one, 30, 29, 28, 27, 26, 25. We are going down one by one by one by one. We are coming up to 6, and finally our final count is 5. So if I just comment this line and then run it, we will see the result is only 5. Why? Because it executes this statement for 25 times, and then after that we get our count. So if we keep subtracting 1, okay, until it reaches to 5, then how many times we are subtracting 1? 25 times, right? So if we actually make another variable called count2, okay, and say it to 0, and every time what we'll do is increment the count2 is equal to count2 plus 1, then we will actually see that the count2 is how many times actually the loop run. So every time the loop ran, we are increasing the count2. So I am expecting it will be 25. Let's see. See, 25. So we ran the loop 25 times and we decrement the count value every time. So 30 minus 25, because we are decrementing the 30 or the count variable each time by 1, and we are doing that for 25 times. So 25 multiply 1 is equal to 25. 30 minus 25 is equal to 5. That's why if we print the count variable, we see 5. See, it's 5. So this was a basic while loop example. So if you actually focus more on what I have just said and try out things, you will understand more. So I wanted to skip the while loop part for now, and this is what I wanted to say about while loop in our first class. And then the final thing is like how to take user input. So everything what we were doing right now is like we are doing by our own, and user have no way to interact with our code, right? But now suppose we wanted to take a user input. So what we can say, like print a line saying give me your age, okay, and after that what we can do is write a function called input, okay, and inside the input also you can actually write this thing. You don't have to write it separately. And then what you can do is try to run this code and see what happens. So we can also store it in a user variable called user input. So what is the value of user input? Is nothing but I am using a function called input function that takes a string that what you want user to ask, and then user will pass something. So if I run, so give me your age, and I will give 60 or like whatever it is, like 23, and then see, nothing happens. Why nothing happens? Because user is giving me his age, I am storing it in the user input, but what I'm doing next? Nothing, right? So if I wanted to see that, I will say print user has an age of, okay, and now we will print comma, and then we will say a variable user input. And now if we run, and now if we say 50, so we can see that computer is saying user has an age of 50. So computer understood that we have given an input of 50, and then it has stored that value inside this user input, and then we have printed it. But one thing I wanted to tell you is that whenever user input something via the console, it is always string type. So this user input and this 50 actually looks something like this, and not a direct 50. Okay, so there is a difference between this 50 and this 50, we all know that. So in this case, to make and we have to convert this 50 to this numerical integer 50. So how do we do that? So there is another function called int, so we will call that function. So now what we are doing is like take user input. User input will become this 50. So what we are doing is inputting this, and what this function is doing is converting this 50 to this. So finally we have our user input to 50. Okay, so I hope you have understood like how everything went. So we are asking the input, then we are getting something like this, and this int function converts this to something like this, and then finally our variable is storing 50. So now if we again print, the result will be same. So 70, range of 70. So now we can use the conditional and write a small program. If instead of user input, we can write here user age, and say if user age is smaller than 6, I will print user is an infant. Okay, and we will use now elif, and we will say if the user age is greater than 12, I will say print user is a teenager, and else if I say print, then I will, or instead of else we can also include more elif blocks. So if I say if user age is greater than 18, or we can also use a new sign called greater than equal to 18. So user is an adult, and finally if we can add more thing, like if user have an age of greater than 60, okay, so we can print user is an old guy, old man. Okay, and finally else. So if every condition fails, what we wanted to say is user is too old to survive. So this is like a funny statement, but anyways, so what will happen is now user, we will say give me your age, and then what number we will enter will come as a string data type. So convert the string to an integer, we will use the integer function, and we will give the input of like this string 50, and then we will get the number 50. Then we will be storing this number 50 or integer 50 into the user age, and now we can compare number with numbers, right? So if user age is smaller than 6, we will say user is an infant. If user age is 12, it is teenager, 8, and so on. And now I want to run the code and show you what happens. Age, so if I give me my age is 4, user is an infant. Okay, if I run it again and say my age is 14, it will say user is a teenager. Now if I run it again, and if I say my age is 24, so it's a user age 24 greater than equal to 18. Okay, maybe there is some problem in our logic. So if we try to debug this, what's happening, why it's saying teenager. So the thing is like we were expecting to say as an adult, but the thing is like that condition greater than 12 is coming at first, right? So the thing I wanted to notice you here is like 24 is greater than 12, right? So this condition passes, so all these condition are actually ignored because 24 is already greater than 12. So what we have to do is put these conditions in a reverse order. So we have to put it in a descending order. So for that, what I have to do is put it here first and start with the highest number first. then we will be getting what we are expecting. So elif user age is greater than 12, then greater than equal to, sorry, let's make it 18. We just have to make it like the reverse order, so that the first condition that came, and now we have to just change it. User is an old man, and then we have to change it to adult, then we have to change it teenager. Sounds good. And here we have to change it infant, sorry, infant. And finally here we have to say user is too young to use this app. But normally you will barely see this statement, will actually never execute. So if you want, you can actually skip it. So if I run now, and now if I press something like 14, I will get a teenager. But if I run this again and press 19, now I'm saying, it is saying I'm an adult, because earlier what is like this condition was before this condition. So as a result, this condition was being evaluated to true, and then user is a teenager was being printed, because the age 19 is also greater than 12, and age 19 is also greater than or equal to 18. So as this condition passes first, it was not executing the previous condition. But as we now change the order of the conditions, or change the order of the backups that we have, now it actually understands that how to evaluate, and now it is saying that we are an adult. And now if we want, and if we run, and then we can say 80, user is an old man. So this is how the things are working. And the main thing I wanted to focus you is like not the conditional part that we have already learned, rather the input part, that you can take a user input. So this is like our entire lecture, and I tried my best to explain you all the things. So I hope everything is little or more or less clear by now. I know that it is very hard to wrap things around on your head when you are seeing a lots of thing in your first time. But the only thing I can say you regarding programming is practice, practice, and practice. The more you practice, the more you get the things into. So I would really recommend you to practice it. And then finally, we are gonna make the final game. So let's get started in making the game. So